Okay, let's continue working on problem B. So let's just, I know the video stopped on this part, but just let me go over what we've written so far. So 2 doesn't have any pairs, A doesn't have any pairs, so I didn't break it down, but I did put a 1 in front to remind myself it has a coefficient of 1. Then we broke down 72 and saw that it was 3 2s and 2 3s. So I wrote -4 times and then wrote my 3 2s, my 2 3s, and then my A. And then we have plus 4 times. And when we break down 8, it's 2 times 4, which is 2 times 2 times 2. And then we also have the A. So notice the index is 2. So that means I'm circling pairs. No pairs there. Here's a pair. Here's a pair. And then on the last radical, we have a pair as well. Remember, this is going to come out as 2. This is going to come out as 3. And this will come out as 2. So then we'll have 1 radical 2a minus 4 times 2 times 3. So what do we have left under that radical? We have 2a. So again, we circled pairs because the index is 2. I just want to remind you from 6.3, whatever the index is, and if there's no number there, remember there's an imaginary 2. So that's why we circled pairs, and pairs come out as a single. So a single 2, a single 3, so it's 4 times 2 times 3. And then these don't have enough to get out of jail, so they stay under the radical. And then for the last term, we have 4 times, those 2 2's came out as a single 2. And then under the square root, we have 2a. Not enough to get out of jail. There's only one of each. So now let's write what we have. We have 1 radical 2a minus 6 times 4 is 24, or 8 times 3 is 24. And then we have a radical 2a. And then we have plus 8 radical 2a. So now we need to look and see if they're all like terms. So we have, breaking this up a little bit, radical 2a, radical 2a, radical 2a. So we have 3 like terms, so now we can add and subtract the coefficients. So 1 minus 24 plus 8, and if you want to do that on your calculator, you can. So 1 minus 24 plus 8. So that would be negative 15. And then we tack on the radical. So there's our answer. So negative 15 radical 2a. And remember, that one's just like one that's on the test, so that's a really good one to study. Make sure you have it highlighted. Okay, let's move on to this next one. Actually, the next 2 are on the test. So we have to break down 150 and we have to break down 600. Wow. So let's go over here in the margin. So 150 is what? 5 and 30? Because 15 is 5 times 3. Add the 0. 5's prime, so circle it. 630 is 5 times 6. 5's prime, so circle it. And then we have 2 and 3. And they're both prime. So that's going to turn into 2 5s. I'm going to put those first. just because they're going to come out because they're a pair, times 2 times 3, and then we have x, x, y. So 2 5s there, then we have the 2 and the 3, 2 x's there, and then we have the y. And we can go ahead and circle the pairs now. So this is a 5, this would x. So every time you have a pair underneath, remember it comes out as a single. So you can see easily now this radical is going to turn into 5x outside. And no pairs here, so those are going to stay in jail. So 2 times 3 is 6y. So there's my first term, all simplified. It was a really big number, but it didn't turn out too bad, did it? Then we have 600 to break down. Yikers. Who made these big numbers anyway? Okay, so let's continue with the tree. So I'm going to do 2 and 300. Like I said, I always like one of them to be prime so I can circle it. And this would be 2 and 150. You could do 3 and 100. You could do whatever. And this is going to be 3 and 50. And then 50, I'm going to go back over here, is 2 and 25. Almost done. And then 5 and 5. So see how important it is to circle your primes as you go, because that's a mess, and being able to pick out all the primes as you go is going to be tough. So make sure you circle them. Every time you get a prime, circle it instead of doing it at the end where you might miss one. So now this is plus 19. And don't forget this is times here. Anytime there's no symbol, that means there's a multiplication sign. And let's list the pairs first. We have 2 2s and 2 5s. So 2 2s, 2 5s, and then we have a 2 and a 3 that are going to stay in jail. And then we have 2 x's and a y. So when you have a really big number like this, I don't think I put one quite that big on the test. It's a really good idea to go back and check and make sure this is correct. So first make sure they're all prime. They are. So this is 4 times 25 times 6. Because that just lets me know that I didn't miss any. I get 600, and that's what I started out with. So that's just a good little check, especially when you're taking a test, just to make sure you got all the numbers covered. So this is going to turn into, these two are going to come out as a 2. These two are going to come out as a single 5. And it's square root. Again, that's why I'm circling pairs. These 2 x's are going to come out as an x. Everything else is a single, so it's going to stay in jail. So let's write what we get here. 5x square root 6y, already simplified, plus 19 times 2 times 5 times x. And then we have square root 6y. See how the square roots are the same? So we're getting close. I'm going to do this one on a separate sheet of paper, so I'm going to go ahead and go up here with that, and then we'll do that one on a separate sheet. So 5x square root 6y is going to stay that. And then we can take our calculator out again to figure out what this number is going to be. Oh, that's pretty easy, isn't it? It's 19 times 10. I didn't see that before I grabbed the calculator. So this is 10 times 19, which would be 190x square root 6y. So remember, we're supposed to be looking to make sure they're like terms. So are the numbers outside alike? Yes. Like for instance, if this x was not there, you wouldn't be able to combine these because those aren't alike. But those are alike and these are alike. So that means I can add them together. So 5x plus 190x is 195x. And then we tack on the square root 6y. Just like if we were adding 5x plus 6x, we do 11 and then tack on the x. So 195x square root 6y. And remember, we don't add exponents in addition. We just keep everything the same. And that would be my final answer. Okay, so let's go ahead and do D on a separate sheet of paper. So I'm going to write it out on my paper. So this is number 2D on page 14. So 9 radical 45 minus 9 radical 125 minus 8 radical 80. So let's just make sure we wrote it right. 9 radical 45 minus 9 radical 125 minus 8 radical 80. Okay, so let's go ahead and work that, and you may want to work it on a separate sheet of paper too. So there is one on the test that is all numbers, no variables. So all you have to do is do 3 trees, circle your pairs because it is square root. And then remember that you're multiplying whatever comes out by these coefficients in front. So we have 45, which is 9 and 5. 9 is 2 3s and a 5. So when I can do them in my head, I usually just do that because 9 times 5 is 45. And we already did, let's keep our time sign there. We already did 125 earlier. Remember how it was 3 5s? 25 times 5, and then it's 5 times 5 times 5. So that was one of the triples you were supposed to remember. And then 80, we're going to have to break that one down because that one is busy. So let's go over here to the side and make a tree for 80. 2 and 40. Circle the prime. 2 and 20. Circle the prime. 2 and 10. Circle the prime. 2 and 5. So it's looking like 1, 2, 3, 4 2s and a 5. So that one looked a lot harder than it really is. So this is going to come out as a 3. This one's going to come out, these two, as a 5. And again, I'm circling pairs, remember, because the index is 2. Here we have 2 things coming out, 2 pairs. So that's going to be 2 times 2. Each one comes out as a single. So let's write our next step. So it's going to be 9 times that 3 came out, radical 5, minus 9 times that 5 came out. And what's left underneath? Radical 5 minus 8 times 2 times 2 and radical 5. So the 2 came out, the 2 came out, so that's 27 radical 5 minus 45 radical 5